Hello, Ren. The ancient Greek mathematician, philosopher, scientist, engineer Archimedes once famously said, "Give me a lever big enough and a place to put it on, and then I will move the world for you." So, you see, for thousands of years, we've known that to change the world, to move the world, all you need is the right tools. In today's cloud era, which has already landed, right? Cloud is no longer a buzzword, it's what we are living in, the era of cloud. The things that the makers of this cloud era, the developers need is the right tools. Hello, everyone. My name is Nikhil Gopinath, and joining me today is Beau Nelford, who is the director of platform engineering at Beau, and Kumar Ramanathan, the vice president of engineering and chief architect at Velocity Global. And we're going to talk about what are the modern tools that's powering the developers in this era of autonomous cloud. And to set you up with the context of this, I'll briefly talk about the motivators, the drivers behind these changes, and we'll talk about the needs of the developers, and we'll head over to see what are the things that Beau is doing to optimize their Kubernetes development environment, and then we'll switch over to Velocity Global and see how they optimize their serverless development environments. So, what are the drivers for this change today? Cloud, like I said, has already landed, right? So DevOps is an integral part of every organization's cloud journey, and autonomous management of autonomous management of DevOps for cloud is an emerging topic. Autonomous anything is now overall embraced by all industries, be it self-driving cars, your cleaning robots, all the way to pilot to cloud and anything you think about has a feet in the door with autonomous. Developers are always looking for new tools to get better and faster with their output, so that they can again go and quickly change the world. And AI is now everywhere as well, and is changing the way we work. So, what is the impact of this? Cloud native development practices needs to evolve. They need to get to a point where you can seamlessly develop across clouds, and developers can be the most productive in their environments. You need a unified testing strategy. You need a plan for data. So these are all some of the impact of these changes that's happening along the developer ecosystem. But for a developer, the needs are still the same. It's still pretty much what it used to be, what they previously needed. They need to develop quickly. They need to be able to test quickly. They wanted their code to be deployed on CI/CD pipelines. They want to ensure that there's a consistent way of testing everything secure, right? So a developer still needs the same thing that they wanted, but now it's in a different context. It's in the context of cloud. So with that, let's head over to Beau Nelford from Beau, and see how they take care of optimizing Kubernetes development.
All right, hello everyone. Like Nikhil said, I'm Beau. I'm at Beau. I've been here for about 2 years, and it's been interesting to see the way that Beau has changed over the last little bit. Let me give you a little context about Beau and what we do. And we serve the small and mid-sized business segment. We are a champion of small businesses. We love to automate their back ends and make sure that they can do things very well. And it's our vision to be able to be the automation backend for small businesses. Though it's small, we do move quite a bit of money. We just realized that we're about 1% of U.S. GDP in terms of money that we move across our platform. Much of our platform is in Kubernetes. A lot more of it is in Java, but it's a mixed environment with services that have been developed over the last between the last 10 years and the last 5 years, and so it's active. Parts of our platform release very, very, very quickly. As soon as they're ready, they're chunk based, and they're deploying daily in production. Every 11 minutes, I think we average. So our engineering group is about 600 plus development teams, and mostly our stack is in Java and Elixir. We're on AWS, and our front ends with modern JavaScript frameworks. So we do have GraphQL as well as REST, using databases like MySQL, Oracle, Elasticsearch, and lots of various dev tools. Next slide, please. So something that we have done, we've found that our development teams need to be able to test our services in isolation. We don't have yet this architecture that says you can test everything completely as a unit test. And so what we've done is we've made that as these ephemeral environments as like production as we possibly can. So while we're deploying into production with Kubernetes, we realized we could use these Helm charts with the namespace primitive from Kubernetes to create production-like environments with very, very quickly. And so this is what we call our team spaces. Nick Thompson was kind of this was Nick Thompson's brainchild, our architect here. And what he did was he created these dev environments that would allow a developer to spin up their changes completely in isolation from everyone else's. And because we are, trunk based, the developer could deploy their change and test it against everyone else's production services. That way, they got a good idea of what was going to happen in production when they deployed. So this became a very an easy way for development to test what they needed to test very quickly. And then we expanded on this idea. We had and these team spaces actually live in Kubernetes in our AWS environments, and then they die quickly. And I'll explain more about that in just a moment. An additional part of this was this idea of local spaces. So should we have a service or a set of services that is strictly containerized and does not have any other cloud services involved or anything else, even faster feedback, we developed this concept of local spaces, which is essentially like team spaces, but lives locally on the developer's laptop and runs in a Docker Compose file. And what happens is we can also utilize this within our pipelines to isolate testing and speed up and parallelize these tests. We actually spin up, hundreds of copies of our environment within a pipeline to test to test segments of our application at once. It allows us to actually speed up our pipelines quite a bit. Next slide, please. So the way things work is like I said, the engineer creates their feature branch. They make their changes on that branch, and then they go into our developer portal, which I'll talk about in a moment, and we'll spin up their team space with their change versus master for everything else. This will contain everything. This team space will contain everything needed, including all the unique URLs, proxies, service meshes, everything to be able to run their environment. The data that is seeded to that is actually a snapshot of production that has been sanitized to remove all PII, and then uploaded as part of in memory as part of the team space. And so what happens is these have a TTL before they're reaped. Generally, it's about a day, and it will end up saving us compute costs if people don't use them. But most of the time, people are using them because we deploy so rapidly. They're able to use them to test their changes, to share those changes. Maybe have one of our SDETs look at them. It's very, very effective to be able to see what this is going to do in production. And so, next slide. So what we also do in order to allow our development teams to acquire one of these interfaces, we had to build a developer portal as well as a command line interface. So what we had was we developed a tool called DMC, which is Divi Mission Control, is an old name for it. But it was something that was authenticated with our enterprise identity platform, has great authorization controls, and we threw in a bunch of other self-service tools there as well. Additionally, once we had this in place, we were able to build a command line interface, since we found out that our engineering teams weren't as fond of web interfaces as they were of command line. So we built a command line interface to do many of these things and some additional things as well. So I'd like to show you a little bit about what that looks like. So this is our tool, DMC. It stands for Divi Mission Control. It's one of the companies that Bill acquired, and where this came from. So this is our internal developer portal that we have created, and this is the Teamspace dashboard is where we create these team spaces and view the ones that are in flight right now. So this is a live view of all the team spaces that are in flight right now, and it shows their name, their status, their age of when they were created, when they are going to be destroyed, their endpoint, who authored them, the GitLab pipeline that created them, their Kubernetes information, their Divi mail address, and some actions that we can take with some of these to update, the TTL or the branch config that they're on, and we can also throw them away. I'm going to walk through how we create a new team space, and this is our current dialog where we have this. So I'm going to put in something like doodle test. And I'm going to select this team space type, which is just going to be our spend and expense core. And I'm not going to specify any specific branches. I'm just going to do these doodle tests, and I'm going to select create. What this was this created a GitLab pipeline, which then is going to be kicking off, that has all of these parameters that we had, which will say it'll have these specific this specific setup, these specific pods, and once it's created, it'll show up on this list of doodle test. So there's a couple different ones in here, but it'll just take about 2 or 3 minutes. Additionally, so as that's spinning up, I want to also show a different way to interact with this, which is through our command line system. So we have this tool called BCLI, which BCLI has a number of things. It's big. I think we update this message every now and then, but it's basically the Bill CLI. So there's a lot of different things that we can currently do with this BCLI tool, but this is also a tool that we created in-house to help our development teams. And one of those commands is actually our team spaces. So we can say team space, and from there we get a list of all the different things that we can do with those. So here I get to list my team spaces, and I think because it will probably want to authenticate. So it's now authenticated with DMC, and now this tool just listed off all of my all the team spaces that are there. It's the same view as this other window here that's showing all the different team spaces. And so here is my doodle test that I just created that is now available. Other things that we can do from this team space, this command here is update. We can delete if we want to delete our team space as well. We can list the projects or the groups or interact with an application. So once these get created, I'll check the status on here of our doodle test. DNS is not ready just yet. But if we want to look at one of the team spaces that is ready and up and working, we can look at this. I think it was Braxton 01 will have something available here. Nope. Probably want to edit that out. Some of these. But let's go with Tom Hester here. Tom Hester is now running this app.cm dev.cm.dv.co is actually running a version of our build code, and it will pop up as if it were a brand new environment. And you can log in, interact with it, and all those things. And when we'd like to get rid of it, we can either go to our environment and delete it. this is our wrap.doodle.test.co is ready. This is our spend and expense screen. So this is the one we just created, and it's all ready. And the pipeline for it is now should be complete. This is that pipeline, running and adding in all those different services as well. So that is our demo.
So what's next? So originally these team spaces started as part of a Divi was an acquisition of Bill about 2 years ago, and Divi was mostly a spend and expense platform. And this was something that we had been doing for a few years at Teamspace with our spend and expense platform on Kubernetes. And now our job is to go into the legacy Java platforms, which were built for on-prem, not containerized. They hadn't been containerized up until last year, maybe a year and a half ago. And so our next job is to containerize all those services, offer those up in Helm charts as team spaces for those development environments, and end up replacing a lot of our static test environments with these team spaces. Additionally, since the Bill proper services are they're a lot more complex. They have a lot more cloud native services, Dynamo tables, S3 Lambdas, others. What we wanted to do is include Crossplane, which is a plugin to Kubernetes, which allows Kubernetes to actually run the integration with cloud providers. So you can essentially define your cloud services rather than using Terraform or Pulumi or CloudFormation. You can define your cloud services within a Helm chart, and they then get included with a Helm deployment. And so what's great about that is that you can then destroy that Helm deployment and all of its associated cloud services. So that's the next part of what we want to accomplish. Basically expand the maturity of those Teamspace offerings and replace static environments and things that are kind of expensive and hard to maintain with more ephemeral offerings. And that's our solution.
All right. Hopefully y'all can hear me. Hello, my name is Kumar. Thanks, Beau, and thanks, Nikhil, for talking through the sort of the overall picture as well as how to approach it when you're talking about container-based solutions with Kubernetes and so on and so forth. A little bit about Velocity Global. Velocity Global is what is called an employer of record. The best way to think about it is you want to hire talent from anywhere in the world. But in order to do that, then you have a lot of local compliance laws and you need an entity and it's pretty expensive and pretty complicated to do that. So you have to have a certain large size and a critical mass to be able to do it. Well, with Velocity Global, you don't need any of that, and we will hire and employ that person on your behalf, and that person will be working on your behalf, and they'll get all of the benefits and everything, just like a full-blown employee. So that's what Velocity Global does. Velocity Global has been around for a few years, and we are growing and expanding our technology platform. And so that's a little bit about Velocity Global. If you click over to the next slide, we are what I call serverless by default. Pretty much our rationale for doing this is, the graph on the left-hand side that you see is not to scale, but is illustrative. If you think of container-based solutions like ECS, you are basically provisioning this environment, and you're paying for that environment based on how long it has been up, right? So it's a time-based model. Whereas serverless is more of a usage-based model for compute, that you're paying more on a usage-based model. And there are economies at certain scale and certain kinds of use cases where serverless is a lot more advantageous cost-wise relative to time-based billing models like ECS. Of course, you have a crossover point, and at that point, you're probably better off being on a time-based billing model than on a cost-based model. But where Velocity Global is, and where I think for that band is pretty wide, and there's where a lot of folks would fit, is that they could actually have a better cost structure if they are on a usage-based model. But there are also a few other advantages to serverless. What I call time to value, a better time to value, because it abstracts away a lot of the infrastructure concerns from the developers. Simplifies the infrastructure management because you're not managing containers, and you're not managing infrastructure to a certain degree. You're predominantly using, at least in with AWS, you're using native services, and you don't lose anything at all on scaling, resilience, fault tolerance, high availability, and all that good stuff. So comes with a lot of advantages. So if you click over to the next slide, it also comes with a few challenges, right? So it's not all a bed of roses. There are a few thorns in there as well. So what are some of those? Well, it's a different model than what people are generally used to, right? Your typical engineering team is not used to thinking about it in this particular fashion. There are a few problems in terms of cold starts, what is the latency in terms of, how do I optimize for cold starts? There's a 15-minute execution limit, at least on an AWS Lambda. Should I have thin lambdas or fat lambdas? What is the right granularity for a lambda? Should it be just a simple small function? Should it be fatter? And all that. There's how do I handle east-west traffic? There's orchestration. It's Lambda or serverless tends to be a lot more event-driven, and if you're not that familiar with distributed systems and event-based models and architectures and eventual consistency, you have to sort of work your way through it. So those are all design time concerns, and we're not going to talk much about it. There are obviously really good solutions for all of those, but we'll put that aside for a little bit, and just so for the focus of this particular talk. The rest of the development life cycle, which is to be able to develop, build, and test. And then once I have that in a pretty good state, I need to be able to deploy it. And then once I deploy it, I need to operate it in production. And I need to sort of think about that full spectrum. And autonomous development teams, well, that's all. It's entirely their responsibility. But at the same time, how do we sort of overcome the challenges that these things present, right? Testing is difficult because there's just a lot of infrastructure dependencies. Your queues and gateways and whatever your persistence layer is, whether that's Dynamo or Aurora or whatever there, and there's just a lot of dependencies that is just hard to bring to your local. Mocking them is not particularly easy either, and even if you're able to mock it, are you going to get exactly the right kind of behaviors? Is your mock consistently of a high enough quality? Then you can say, hey, why don't I just deploy everything in the cloud and test it there? Yes, but if I'm making a lot of changes rapidly, and I wanted to just make a change, test it, because I'm trying to zero in on a good solution. long deploy cycle times significantly impact productivity. And so we need to overcome those things. On the deployment side, well, there are a lot of tools, but there are a wide variety of them: CloudFormation, CDK, SAM, serverless framework. These all have their own unique variants and things that you need to really understand. And if you're a small autonomous team, you may not have all of that expertise. Plus, that takes a considerable amount of time away from the core business focus that you need to have in order to solve business problems or come up with solutions at a rapid pace. And then on the production operations side, well, how the heck do I even observe this thing? This is like this spins up and goes down, and it's so ephemeral to some extent. How do I monitor something like that? How do I, we talked about latencies, start times, and latency. There's a whole slew of performance optimization. And if I over-index on high performance, and I've got a higher cost, and so there's some complexities that is involved that are involved here. If you click to next, please. Well, our solution to that is to have paved roads. Paved roads is a concept that Netflix started quite a while ago, and paved roads basically means that I have all of the stuff that I just talked about in terms of being able to deal with the infrastructure, being able to work with testing and deployment and production operations. All of that has been coded for a handful of supported languages and supported infrastructure. And as long as your solution space fits within that, then you can just take it and run with it, and you don't have to spend any time at all on building any of the scaffolding. Just trying to keep an eye on the time. For us, when we say paved road is the product. Our internal engineering teams, these domain teams, are the customers of the product, and DevOps is the product owner and is the one that brings the paved road to market. And so that DevOps is the engineering team that builds the paved road and the product that goes with it. There's one way to build, test, deploy, monitor software in a handful of approved languages and stacks. For Velocity Global, we chose Node.js and TypeScript, Java, and pretty much everybody's got to do Python because of data science and AI needs. If you're trying to use anything else, then you're off-road and you have to build all of this infrastructure all by yourself, and that serves as an incentive for you to really think about your choices as to, do I have that big a need which cannot be solved by one of these supported platforms? And the paved road already includes things that are common, routing, API routing, authentication, authorization, all of those are built into it. So essentially, if I can sort of adopt a paved road, I can start developing, and all of the scaffolding that you think of when you start off a new project, and it's already there, and you don't have to spend any time at all on it. So how does the DevOps engineering team measure paved road? Well, the customer NPS is just like any other product. The customer NPS is a critical metric, and in this particular case, our customers are internal developers. So the developer NPS, DORA metrics that everybody's familiar with, and we also want to make sure that you don't have DevOps or QA or somebody else involved. And so what happens here is you want the fully autonomous team to just own the service end to end and feel this complete ownership on driving it. So I have a little picture on the right that kind of talks about, or the component parts of it. There are templates and pipelines and workflows that at the end of the day executes the tasks. So So that's the solution. So I'm not going to attempt a demo like Beau did, but what I have is a couple of screenshots, which I'll try to run through really quickly. This is README from our Paved Road repo that our developers use, right? So this is the actual content of it. So there are four things on the right hand side for setup. That we have a private npm repo, and I'm just using TypeScript as an example here. We have an npm registry which contains our approved security engineering cleared dependencies and packages, including our common packages. And the developer themselves will have their own AWS credentials for their local development work. And so all they need to do is to set up the project locally. And if you're starting the project new, you will clone it. That's what you see on the right hand side. You'll clone the Paved Road repo. The Paved Road repo basically has a Hello World app that fully deploys into our infrastructure, including monitoring and everything built in. You install and build it, and then for your app, you would want to sort of update some environment variables, and that's you just go into this JSON and update it. It has a little bit of a hierarchy, a little bit of a structure, which says there's a shared, which is common across all environments, and then there's local development, test, staging, and production. These are the various environments for your service. So you just define those, and you just deploy it using that third step, and now all of a sudden you have a fully deployed version of the app in your local AWS credentialed isolated area that you can now build and test. If you click to next one, please. Testing, we talked about, is an interesting problem in and of itself. With so many other dependencies, like infrastructure dependencies, your full complete view you're going to get only when you are in the deployed environment. And Beau talked about this as well when he talked about this from a Kubernetes perspective. So you want all of the integration testing to be happening with full infrastructure. But you can do unit testing locally, because a Lambda is just a function, and you should be able to mock. You should be able to sort of request and get a response within the local. So unit tests are run entirely locally. And then there are some dependencies that are mocked, which are then run in local integration. This sort of gives a little bit of the flavor of the dependencies and still gets you a lot of speed. And then you run integration testing in the deployed, in your local deployed space. And you can we use SAM syncs. This is built into the Paved Road. So when you make a modification to your code, that code gets synced over, and you don't get the whole infrastructure deploying every single time. Only your modified version of the code comes in. So you come around and make the request. Your modified code is already available, and you can sort of get that tight loop for testing. And then we use CrowdA to do our full-blown integration testing and also integrate all of that into our pipeline. Next, please. So how do you deploy? Well, very simple. You put your environment variables for all of your other environments, and the pipelines take care of deployment. The pipelines contain a whole bunch of tasks in it. It runs linting, it runs unit testing, it runs scans, static and dynamic, and it does all of those things. And then it runs the deploy scripts and deploys it. And now all of a sudden you have it in the environment that you need. It is all built into the CI/CD workflow. If you click one more, please. Well, how do you sort of monitor this in production, right? So our SAM templates come with Datadog. We use Datadog as our monitoring, and each individual team then sets up their own alarms and PagerDuty to go with that. And then we have hand curated cost tagging, utilization, and performance dashboards, and then that's what the teams use to optimize further. So that's just the evolution that we're in. As we scale where we want to go into hands-free optimization, using autonomous tools, auto-managed provisioned concurrency, and these are all where Sedai, does exceptionally well. And it takes even that cognitive load from the development team in terms of how do I manage all of these things away, and makes it simple and straightforward. So that is the end of my talk, and that is how we do serverless, and we make it painless and productive for our developers.
That was really interesting. So in the interest of time, I just have one question to both of you. So it looks like with paved roads, you had figured out how to develop and accelerate the developer's journey in the cloud. And with a deployment every 11 minutes, Beau, that's really, I can't imagine how you would do that without something like this. So the question for you is, so with someone who's impressed by this, right, where do I start? Are there any commercial tools or open source tools that I can start looking at as a starting point for my journey if I want to adopt these practices?
Yeah, I think that whether you're on a serverless framework, and I'll let Kumar talk about that, but if you are in a world where containers are kind of the main stage of things, Kubernetes is really great for this. It provides so many different ways to start and stop things. The orchestration part of it is just something I recommend. I would use a managed service like EKS or GKS or others where you don't have to maintain most of it. But the services and the plugins that community provides there are really phenomenal. If you don't want to manage servers, there is the option of using Fargate and other serverless components, but that is the base, that is the foundation. Of course, there's also developer. If you haven't started an internal developer portal, there are services from companies like Spotify, like Backstage, which allow you to do that kind of with batteries included in so many ways. There's lots of plugins that you can provide right away. There's interactions with your cloud providers and identity platforms and things like that. So the first thing would be just to say, but understand what your environment looks like, what your ideal environment looks like, and then work backwards. Use the Amazon principle of working backwards and of how to get there into your environments. Additionally, I would talk with your developers. I loved how Kumar talked about how they measure their performance with NPS, internal NPS. But talk to your developers, talk to your engineers, talk to them and understand what they really, really want, and then provide them something and iterate. That would be probably the best advice I could give.
That's all tremendous advice, right? I think the one other thing that I would sort of add is start with whatever tooling is available provided by your cloud provider, because it's probably better integrated into the core infrastructure. So for us, we basically say we're in AWS, and we're not looking to have vendor independence necessarily, and something that's core like that, and we'll deal with it if AWS goes under, I guess. We start with, hey, does AWS provide a solution, and is that solution good enough for what we need? And if it is not, then we expand it and we start to look at something that is broader. In the serverless world, there's more every day that is emerging, more tooling, both from an open source community, including AWS investing a lot more, and open source communities doing more, and commercial solutions are available as well. So, but start with native, and then look at the best solution. If the native solutions are not there, then look for the next best solution, and try as much as possible to automate and make it so that this is sort of people having to delve into it is only because they are really passionate about what is under the covers. Otherwise, it just works. And at a utility level, availability and reliability, it just works. Right. And there's a lot of power in doing that. So that's what I would recommend.
Right. Thank you, Kumar, and thank you, Beau. That was very enlightening, and thank you for taking your time to give us all these insights from your end.